Hi, my name is John McMaster, and greetings from my Silicon Valley semiconductor garage.
Hi, I'm Yusuf. Welcome to Geek Moniker. Today we have a very special quick lab notes episode for you. So take it away, John.
Hi there, thank you. So what I have here is a reactive ion etcher that I've been repairing. And basically what that is a plasma etcher, which allows me to do things like clean computer chips and very selectively etch in special ways. But the focus of this video is not the plasma etcher itself, but rather a repair process I've been doing on the etcher. Yusuf, do you know anything about high vacuum or kind of what that might mean?
No.
So a lot of times for a lot of semiconductor tools, you need to have no air in the system. It needs to run at a very low pressure, and maybe things like oxygen or nitrogen could actually be considered harmful for the process going inside there. I'm not an expert on plasma physics, but in particular, it needs to run at a pretty low pressure, nothing close to what we get in the atmosphere. Have you seen kind of neon lights, kind of similar like that, okay?
Yep.
Sure. So with that in mind, I got this on eBay a while back, a relatively good deal. These tend to be relatively expensive, but this machine needed a lot of TLC. So I've been going through and fixing a lot of things on it. Now, the most recent thing is there was a valve that was installed here, and I posted some pictures on Twitter a bit back showing me taking apart that valve. Did you happen to see those?
I actually didn't catch those pictures. No.
Okay, well, I took a valve out of here, and what I found was there was like crud that had accumulated from the previous owners. There's like chips that had fallen down, like the gasket was eaten. It was like something you call a plumber for. Like it was gross in there and kind of just falling apart. So what I did was I started taking it apart and I had a little bit of troubleshooting. So we have here, this is a vacuum valve. So what we have here is a flexible bellows that as you have this plunger that goes in and out, and what you do is this would connect on here, and you'd have a kind of a valve on the end of this. So you turn this lead screw, and this moves this in and out and keeps it vacuum safe with this accordion seal. I started doing some experiments, and I found out that even after cleaning and repairing all this stuff, the vacuum level would depend on the valve position. And so the question is, for a system that is sealed, should it matter where I move this?
I guess not.
No, it shouldn't. And so what that indicates to me is that there's some sort of stress on here, which is leaking, where if it's not compressed in exactly the right way, that crack is opening up. Do you know anything about diagnosing microfractures like that?
No. Take X-rays maybe.
Sure, potentially. This is stainless steel, so steels tend to be relatively opaque to X-rays. And maybe if I had high quality, 3D tomography equipment, that might work. Unfortunately, at least with the equipment that I have, I don't have anything precise enough to do with that. But sure, that would be one possible way to deal with it. Um,
Could you do the soap test?
aha, tell me about the soak test. What is the soak test?
So you take some soapy water, put it
Yes.
around the thing, and then shove some air through it, and wherever it bubbles up, you got your leak.
Sure, and so that's actually a good thing. I should have mentioned that. That is actually where I did start testing, was I pressurized this system, much to the chagrin of some people on Twitter who were not very happy with that decision. There's a whole thread about that if you're curious. But at least for me, I think that was good. And using that and some solvents, I was able to narrow it down that it's somewhere in this area. But partly due to clearance issues, it's very difficult to see inside there, especially with this cover on. It kind of blocks everything. I really can't see. Unfortunately, I wasn't able to use that to specifically locate the leak. But yes, in many circumstances, that's a great way to narrow it down. So good suggestion, but I wasn't able to solve it. Do you have any other suggestions?
Hmm. No, actually, that was the one I was thinking about.
Okay, well, there's a good suggestion. Another way that you might approach this is there's like CSAM, like confocal scanning acoustic microscopy. So like ultrasound, sometimes people will use to do this stuff. Unfortunately, this is a complex geometry. I'm not sure that would work well. So what was actually suggested to me was dye penetration testing. Do you have any experience with that?
No, but I would think you put some dye in there, and wherever it leaks out, it leaves a mark.
Close. So because it's such a small fracture, you may not be able to actually get the dye all the way through. So what you do instead is you take first a dye and you spray it on the part and you let it soak in for a little bit. And then from there, you kind of wipe it off very gently. So the idea is that you've soaked some dye into the part, but you've wiped it off the clean surfaces. So maybe there's little crevices that have dyes, but because it's in that crevice, you may not be able to actually see it. So then what you do is you spray a developer on, and what that basically does is it wicks the dye out of these crevices, and then it shows it up with this developer. And so this was the plan, and that's how I was hoping to find a little small leak on here. But at some point, I started questioning, and this is just a cleaner to the right to get that dye off. I started questioning, though, do I need this? And sometimes that is the simplest engineering solution. If you have a defective part and you decide that, you know what, I don't need air conditioning, maybe you just get rid of the air conditioner. So in another move that Twitter was very excitable about, I decided to 3D print a vacuum flange, which is what you see in here. So I know you do some 3D printing, right?
Yep, I've been doing a bunch lately.
Sure. Vacuum parts like to be like nice, very solid metal things with no air pockets in them. Does 3D printing conform well to that?
Maybe.
And that's actually an accurate statement. It did sort of work, but even with all this high vacuum grease I coated on, it wasn't the best thing. So I turned to our manufacturing partners again, and I actually just got these CNC machined, and I'm going to install this on here and just blank off that shutoff valve entirely. On the back of this, I guess I can move this around. On the back of this, if you can see there, kind of, you can see I actually have so I have this manifold set up, and I actually have a shutoff valve that I've installed. So at least for the time being, I'm going to use my own shutoff valve, and I'm just going to ignore the initial valve on there because it was problematic. I may try to fix it at some point, but even if I find the leak, I would still need like a TIG welder or something like that to fix it, which I don't have. So I'm curious to figure out what the original issue was, but I decided it's just not worth the effort at this time. So that's what's been going on in the McMaster lab, and hopefully now with that sealed off, I'm going to try soon to ignite a plasma in here because I think just about everything is put together now. So hopefully.
Hey, best of luck. Don't go boom.
Thank you very much. Well, I think that's all I have, unless you have something else you wanted to add.
I've been working on something this week, but I think I need a few more weeks to actually show it off. It's been some pretty interesting jury rigging to get this thing to work. So, it'll make for a good story.
I'm looking forward to it.
All right. Hey, thanks a lot for watching. Have a good week.
All right. Until next time.
Bye.